Engineering Dynamics, Session 8, Kinetics of Particle Angular Motion. So in motion, we have a normal motion in which we have a displacement like capital S, velocity like v, and acceleration. We have the same terms in angular motion with like theta. It's very identical to S in normal motion. We have W, which is the velocity, angular velocity. It's again a very similar to velocity in normal motion, and alpha, which is replaced to acceleration or A. If you remember in normal motion or rectilinear motion, if we are moving from location A from with the specification of S to S plus delta S, likewise we have in angular motion, we are in a angle of theta, then go a bit farther, and that's theta plus delta theta. That's in angular displacement. Likewise, in angular velocity, we have instantaneous angular velocity, which is W limit of delta theta over delta t. When delta t is very small, it drives all the way to zero. That's theta dot or d theta over dt. And the average one, which is, we can just show it by delta theta over delta t, just a bit longer time span in comparison to instantaneous. Instantaneous velocity is at the moment, but the average one is just you are dividing over a span of time. So in angular motion, likewise we do have displacement like by show that by like theta, velocity by w, and acceleration by alpha in angular motion. If you remember, in rectilinear motion, in normal motion, we have velocity like the variation of displacement over time, and we can also show it by s dot. A acceleration is variation of velocity over time, and that's v dot or s double dot. And if we just write down both of these equations just based off dt, can reach to an equation which is v times dv, velocity times variation of velocity is acceleration times displacement. Or you can show it by s dot. We call that independence from time relation. That's interesting because we just remove the effect of time from both equations, and we just relate the displacement, velocity, acceleration all together without time factor. Likewise, we can write the same equation in angular motion like w over d dot. Alpha is dw over dt, and that's w or theta dot, my bad, w dot or theta double dot. And you can also likewise write this equation like w dw is equal to alpha times d theta, or if you replace w by theta dot times alpha by a double dot, that's again they are identical to each other. That's again independent from time equation for angular motion. Like normal motion, we have also different scenarios. If a is equal to 0, a is constant, a is a variable, acceleration is a variable of time, velocity, or a displacement. We have the same like alpha is function of time, alpha in angular motion. This is normal motion, and this is angular. And by normal, directly, or function of displacement or velocity or time. If alpha is 0 or alpha is constant, or it's a variable of again time, velocity, or displacement in angular motion. So in the first case, alpha is equal to 0. That means variation of velocity over time is 0. Definitely time is not 0. Variation of time is 0. Variation of velocity is constant. So you can continue and write the equation like theta is equal to w times t plus theta naught. And that's exactly identical to normal motion, which we say S is Vt plus S naught. A displacement of x is equal, that's exactly x minus x naught is equal to Vt, just x equal to times t plus x naught, which is the initial velocity. You can write that also for angular motion. We solve a talk about the curvilinear motion at tangential format. Solve a problem on that in next video. Thank you.